Today, we're going to go over the process of creating cube maps in Unreal and Unity. Let's go. So I thought of several new topics that I want to cover on the channel and new effects that I want to create materials and shaders for. And a lot of them used cube maps, and I realized that I haven't shown you guys how to actually create cube maps yet. And this might be an important skill for everyone to know. So what we're going to do today is I'm going to show you the mechanics of how to create a cube map. But before I do that, I want to step back a little bit and talk about what a cube map is. I think this image illustrates it the best. What we can see here are 6 sides of a cube. You have the top and the bottom, the left and the right, and the front and the back. And so basically we have 6 images, and they represent the different sides of an environment. So when taken all together, these 6 images represent the whole environment. And if I stand in the middle of this cube and I look to my left, I can see what's over in that side of the environment. I look to my right, I can see what's over there. I can look up and see the sky, and I can look down and see the ground or the water. And so these 6 images represent the entire environment for me. And so this basically what this is a shortcut. So if I pre-render my environment into a cube map, then when I want to sample it for like reflections or other effects, I don't have to render my entire environment. I can just go and do a texture fetch and sample my cube map. And so this is an optimization that we use in real-time computer graphics for rendering things like reflections and refractions and other effects like that. And this is really, really common. And so what we're going to do now is I'm going to show you the process of creating these cube maps and then bringing them into both Unity and Unreal. So the first thing that I would want to do is capture these 6 images. And I could paint them myself, or I could render them from my environment in Unreal or Unity. And so I would just add a camera to my scene, and I would set my field of view to 90 degrees, and then I would set my aspect ratio to square, and then I would capture these 6 images. Now, once I have my images, I can bring them into Photoshop or GIMP and assemble them. So let's take a look at that next. All right, so here we are in Photoshop. And first of all, I'm going to go through the process of assembling the images to bring them into Unity. So here on the top, what you can see is I have a single image, and I've taken all 6 of the images that I captured from the environment, or in this case, they're just these utility images that represent the 6. And I've lined them up in a row like this. So my images are 512 by 512, which means if I line them up in a single image like this, my final resolution is 3072 by 512, because it's just basically 512 times 6. So if your images were smaller or larger, you can just take your height resolution, whatever the height of your individual images is, and multiply it by 6 to get the width. And then you just lay your images out in a row like this, 1, 2, 3, 4, 5, and 6, with the x-axis being left and right, the y-axis being up and down, and then the z-axis being the front and the back. So that's how you arrange your images. And once they're arranged, you can just save it as a ping or a TGA or whatever kind of image format you want to use to bring into Unity. And then let's switch over to Unity and take a look at what needs to be done there. All right, so here I am in Unity, and I can just right click in my project and pick Import New Asset. And then I can pick the ping file that I saved. In this case, I called it World Cube Map Ping. And it'll import it. And let's bring up the properties so that we can take a look. Now you can see that it's imported it just as if it were a regular image of 6 pictures in a row here. And you can see that the texture shape is 2D. And this is what I want to change. I want to set the texture shape to be cube. So I set it to be a cube map. And then it exposes these new settings here. My convolution type, my mapping, I'm going to set to 6 frames layout. So basically I'm telling it, hey, look, I have a collection of 6 frames here, and I want you to make those into a cube map. I could also bring in a texture in latitude, longitude format, which is a format we talked about previously, and it would convert it into a cube map. Or a sphere map, I could also make that into a cube map. So Unity has a lot of built-in features for making cube maps of various import formats. In my case, my import format is 6 frames layout. So I'm going to pick that. Then for convolution type, I'm going to pick specular. And I'm also going to turn on fix up edge seams. Now I want to take a minute and explain what this means. Convolution type is the way that it's going to generate the MIP maps of my cube map. And basically, when I set my convolution type to specular, what that means is the MIP maps in my cube map are going to represent different smoothness and roughness measurements. So I can sample different MIP levels of my cube to represent the smoothness or the roughness of my surface. So it's going to sample MIP 0 if my surface is perfectly smooth, or I could tell it like, hey, sample a lower MIP if my surface is rougher. So that's what it's doing when it's talking about convolution. If I were to pick none here, it would just create MIP maps as it normally does for a 2D texture. But since I'm picking specular, glossy reflection, it's going to use a different style of MIP map creation that blurs the MIPs according to the way that smoothness and roughness work. Fix up edge seams means that on the edges of the cube where 2 faces come together, when it's blurring the faces of the cube to create lower MIPs, it's going to fix up the seams across those edges so that the edges blend together. That's a great feature, and that's what I want. All right, the next thing that I'm going to do is I'm going to pick none for my alpha source because I have no alpha channel. And then I'm going to come down to the bottom and hit apply. And when I do this, what you'll see is now it's converted my cube map into a reflection sphere here, which indicates that instead of just an image of 6 pictures in a row, now I actually have a cube map image. All right, and that's all that there is to it in Unity. Unity makes it really easy to bring a row of 6 images in as a texture and convert them into a cube map. So now I can grab this cube map that I just created and drag and drop it in, and it creates a sample reflected cube map that I can then plug into my base color or my emission. And you can see that my reflected cube map is now working correctly. And I can use this for reflections or refractions or a bunch of other techniques that we're going to get into in a later video. All right, let's switch over and talk about what needs to be done in order to get a cube map into Unreal. So here we are taking a look at the documentation for Unreal Engine. And here's their page on creating cube maps that I'll link down in the description. This documentation refers to this tool called the NVIDIA Texture Tools plugin for Photoshop. And the reason that we need this is in order to create a texture and bring it in as a cube map in Unreal, I actually have to save it out in DDS format. And so let's switch over to the NVIDIA website. And we have this tool on the NVIDIA website that's called the NVIDIA Texture Tools Exporter. So if we scroll down here, you can see here's the downloads. We want to download the Adobe Photoshop plugin which will allow us to create textures in DDF or DDS format. Now, I'm using an older version of Photoshop just because I don't like Photoshop's subscription model. And so I just bought Photoshop a long time ago and I've stuck with that. And because I'm using an older version, I have to download this legacy version for Photoshop for Photoshop 5 to CS6 because I'm using Photoshop CS4. So I'm going to download that plugin and install it. And if you're using a newer version of Photoshop, obviously you'll want to download this version of the plugin here. And this is going to allow us to save our texture as a DDS. Now, if we look at the documentation again, there is another requirement, and that is we need to format our cube map like this picture describes here instead. So let's switch over to Photoshop and I'll show you what that looks like. All right, so here we are back in Photoshop, and you can see that for Unity, we could just arrange our images like this for left and right, top and bottom, and front and back. But it's a little bit different for Unreal. Here's the texture layout that we have for Unreal, and you might be asking yourself, like, why in the world would I have these really weird orientations for the Unreal version of the cube map? And the reason for this is that DirectX and the DDS texture format are assuming that you're using Y up. And so if your Y axis is up, all of your images are flipped correctly so that they look normal. But in Unreal, we know that Z is the up axis, which kind of goes against the DDS and DirectX formatting. And so we have to do some interesting things because the world is rotated so that Z is up. We have to rotate our cubes here a little bit and rearrange things so that we get the proper layout. Okay, so this is what the example cube map that I'm using looks like for Unity. But for Unreal, you can see that I've had to rearrange things a little bit. For my left and my right images, I had to rotate the left one 90 degrees counterclockwise, and I had to rotate the right one 90 degrees clockwise. Now my top and my bottom images here are on the Y-axis for Unity, but for Unreal, my top and bottom images are on the Z-axis, and so I had to move those images over here to the right side of the layout. And I also had to invert the bottom image 180 degrees. For the front and back images, instead of having those over here on the right side of the images, now they're in the middle, and you can see that just like this 3 is upside down here, I had to flip this. Anyway, it might take you a little bit of trial and error to get these images in the proper layout. I know I had to save it and import it and look at the result and then rearrange things a little bit. I had to do this a couple of times to get this right. But I was able to finally get each of the images in the proper layout so that they would import into Unreal correctly. And hopefully taking a look at the way that this template is laid out and the relationship between this image here for Unreal and this image here, or this image here for Unreal and this image here for Unity, will help you see what needs to change in these images in order to get them to work correctly. All right, the last thing that you need to do is use that Photoshop or use that NVIDIA Photoshop plugin to save this as a DDS format. So for Unity, I could just save it as a ping and then import that and tell the engine to format it correctly as a cube map. But that doesn't work for Unreal. In Unreal, I need to save it as a DDS format, and I'll show you how to do that right here. So I go File, Save As, And then for the type, I drop this down. And if I have that NVIDIA plugin installed correctly, I can pick DDS as my format. And so I'm just going to go ahead and save this as World Cubemap Unreal. And now I have these settings here. And for the compression settings, this drop down at the top, I'm going to pick 8888 ARGB 32-bit unsigned. And what that is uncompressed. Now don't worry about it. We can set the settings in Unreal for it to be compressed, but in order for it to be able to import correctly, I have to set it to be uncompressed. Now the type of texture I'm going to pick is a cube map, and then the for MIP settings, I'm going to pick no MIP maps. Again, I can generate MIP maps in Unreal, but here for the raw version that's going to be imported, I have to pick no MIPs. So I'm going to hit save. And then let's switch back to Unreal. So here in Unreal, I've went ahead and imported my cube map. And you can see that instead of those 6 images, it's rearranged things so that it's previewing my image as a latitude-longitude projection. And up here in the details, you can see that it's a cube map. And you can see that my compression format is DXT1. So even though the DDS file that I saved out of Photoshop was uncompressed, you can see that Unreal has gone ahead and by default, it's compressed it to DXT1 here. You can see that I have my gamma set to sRGB, and that's true because my image represents color. And then everything else can just be set to the default settings. All right, let's take a look at an example shader here. You can see that I have my texture sample. And for the sample, I have my cube map selected here, World Cubemap Unreal, the one that I imported. And once I set a texture that is in cube map format, you can see now that there's this error here if I don't have any UVs connected. And if I bring in texture coordinates and I try to connect those, you can see that it's still erroring out. And basically what it's saying is that, hey, this is expecting a 3-component input, but it got a 2-component input instead because texture coordinates are float 2. But because this is sampling a cube map, it's expecting a vector, which is a float 3 instead of a float 2. So I can't use regular texture coordinates to sample my texture. I have to actually use a reflection vector. So if I type reflection here, you can see that I have a node here that's a reflection vector in world space, and I can sample, or I can use that as my input UVs. It's a little bit confusing because UVs are typically float 2, but because I'm sampling a cube map, I actually need a float 3, which is a direction vector, not UVs, but that's how it works. All right, you can see that once I'm using my reflection vector with my imported cube map, now I've got some pretty cool looking results. I've successfully imported my cube map texture, and I can sample it using my reflection vector. I can also sample it using a world space normal. So if I bring in my vertex normal world space or my pixel normal world space, I can use that vector to sample my cube map. But you can see if I do that, it makes it look like the reflections, instead of being reflections, they're just stuck to the surface. But that is an alternate way of sampling the cube map. All right, I hope this video was helpful and that you learned about cube maps. If we switch back to Photoshop here, you can see we have 2 really different formats and ways of going about getting cube maps into Unity and Unreal. Because Unity is Y-up, we can just use the standard layout for DirectX and the DDS texture format here. But because Unreal is Z up, we have to do a little bit of shenanigans here to get our images looking correct. But anyway, once you get past all of that and you get the data into the engine, you can use it for a lot of cool things. So starting next week, we're going to be taking a look at some techniques that you can use to use Cubemaps in your shaders. So I hope you come back next week and look forward to that. Thanks for watching and have a great week.